Let's talk about the biological clock. You've heard the term, right? And you've probably heard the number that always seems to come with it, 35. It feels like this magic number in any conversation about fertility. But why? What's really going on inside our bodies that makes this particular age so important? Well, today we're going to get into the science of it all.
Okay, so let's just get right to it. This is the big question, isn't it? And it's not just some made-up social timeline. There are very real biological reasons for the shift. And the answer, it turns out, is hidden in the data from a huge scientific study. To really get a grip on how age changes things, we have to start at the very, very beginning, with an embryo's genetic blueprint. You can think of it like an instruction manual for building a person. Every single cell needs a perfect, complete copy to work.
And that brings us to a word you're going to hear a lot, aneuploidy. It sounds complicated, but the idea is actually pretty simple. It just means an embryo has the wrong number of chromosomes. And this right here is probably the single biggest hurdle in reproduction. It's a leading cause of miscarriages and certain congenital conditions.
So, to stick with our metaphor, a healthy or euploid embryo has the complete instruction manual. All the pages are there in the right order. An aneuploid embryo, though, it's like that manual is missing pages or has extra ones shoved in. It makes it really tough and often impossible to follow the instructions correctly.
So, how common is this problem really? Well, that's what researchers wanted to find out, and they did it by analyzing over 46,000 embryos in one of the biggest studies of its kind. So this isn't guesswork. This is a deep dive into some serious data to see exactly how a woman's age affects her chances of having a genetically normal embryo.
And you can really see the decline in detail right here. This chart shows the probability of getting at least one healthy euploid embryo in a single IVF cycle. Look at age 35. You've got an 85% chance. Pretty good, right? But then, by age 40, it's already down to 75%. And by age 44, it's plummeted to 45%. It's not a slow, gentle slide. It's a steep, accelerating drop.
And to put it another way, the study found that, on average, a woman in her late 20s makes about 4 genetically normal embryos per fertility cycle. Think of this as our baseline. This is pretty much peak fertility, according to the data.
Now get ready for the contrast. After age 42, that average number drops to less than 1. From 4 down to less than 1. That stark difference right there is the heart of the age 35 question. It's really just a powerful and pretty unforgiving numbers game.
But the research also uncovered something else, a really fascinating part of the story. You see, fertility specialists often check on embryos at 2 different times, on day 3 of their development and then again on day 5. And what they saw tells us a ton about nature's own built-in selection process.
Okay, let's break this down. On day 3, you've got more embryos in total, but a smaller chunk of them, only about 35%, are genetically normal. Now fast forward to day 5. A lot of those embryos have stopped growing, so you have fewer overall. But, and this is the key part, of the ones that made it to day 5, a much bigger percentage, around 55%, are chromosomally normal.
So what on earth does that mean? Well, the scientists put it perfectly. The reason so many embryos disappear between day 3 and day 5 is because they were aneuploid. They had the wrong instructions from the start. It's like nature has this incredibly powerful and very early quality control system that just weeds out the embryos that can't develop properly.
And the study really drove this point home when it looked at egg donors. Because donors are typically much younger, using their eggs helps get around these age-related problems. It confirms that the critical factor here isn't the age of the person who's pregnant, it's the age of the egg that started the whole process.
All right, we've gone through the science, the numbers, the whole shebang. Let's zoom out and pull this all together. What's the big picture here? What are the main takeaways from all this, and why should you care? So first off, that biological clock is basically just a story about aneuploidy. The sharp decline after 35 is tied directly to that rising rate of chromosomal mistakes. Second, it means the number of healthy embryos you have to work with each cycle drops a lot as you get older, which is really important for setting realistic expectations. It also means that for younger people, if IVF doesn't work, aneuploidy might not be the main culprit. You know, at the end of the day, this information isn't supposed to be scary, it's supposed to be empowering.
And that leaves us with one final thought. For so long, the whole conversation about fertility and age has been kind of vague and, let's be honest, full of anxiety. But now that we have a clear scientific picture, we can start to move from just mystery and fear to actual understanding. Knowing the why doesn't change the biology, of course, but it can absolutely change the conversation, the way you plan, and your perspective on the entire journey.